Codeforces round 658, division 2, problem D, Unmerge. We're given an array P of size 2n, and we're asked whether we can split this array P into arrays A and B of size n, so of the same size, such that when A and B are merged using the merge subroutine of the merge sort algorithm, we receive the array P. So to gain some intuition about the problem, let's see how A and B will get merged together by the subroutine merge of the merge sort algorithm. And let's pay special attention to the largest element in both arrays, 8. We'll actually see that 8 has some interesting properties and that it protects everything after it. So here we've simply compared the first elements from both arrays, taken the smaller element, moved it to the beginning, and then we're going to now recursively merge. So we're going to do the same operation again. And notice how 8 is protecting the 4 after it. So 8 forms a contiguous subarray. So now let's highlight all of the elements that are greater than all the elements that came before it. The motivation for this is that they will also have the protective property, and that they'll protect all the numbers after it up until the next larger number. So now that we know that these contiguous subarrays are going to be preserved after we do our merging, all we need to do is see if there's some concatenation of subarrays that will add up to size n. This just evolves into the subset sum problem, which can be done in polynomial time. To do our subset sum, we'll create a 2D array with the columns being all the numbers from 0 to the sum target, and the rows being all of our different options. We'll ask ourselves the question, can we create the sum in the column by using the numbers that we've seen so far? And we'll start from the top left, go to the right, and then go down. Of course, we can only make the number 0 when we only have 0, and we can make 0 using any of the numbers. In fact, once we've seen that we can make a number, all of the subsequent values in that column will be true. Now, so far we've only seen two cases. The first being when the value that we're looking at is the same as our target sum. So let's say the target sum's 1 and our value is 1. Yes, of course we can make 1 with 1. The other case being when we've already proven that we can make the target sum. So let's say on 2, when we're on the row 2, and we're looking at the target sum 1, yeah, it's been shown already that we can make 1 given the numbers we have so far. Now, the third case, the most tricky case, is when neither of the previous ones are true. So our target sum is 3, the value we have right now is 2, and we've already seen the values for 1 and 0. What we can do is we can go up one row, so up one row from 2 to 1, and then go back 2, so the number of our values, and we'll land on the spot target sum 1, value 1, which is true. And all that's saying is that if we take our target sum and we subtract our current value from it, can we make that new target sum? So if we take 3 and we subtract 2 from it, can we make 1? And it's true. So we can actually make 3 using all the numbers that we've seen so far. So we've done our subset sum. To do that, we use dynamic programming, where we just went and we checked whether we can make all of the target sums up to our final target sum using the numbers we've seen so far. We finally got into the column 4, which was our n in our original problem, and we've seen that yes, we can add some subsets with some lengths such that we get a clump of subsets whose length is 4. And this is actually the end of our problem. We've actually proven that we can split our original array P into 2 subarrays of both size n, such that when we perform our merge algorithm, we get P.